All right. So any question about the process so far about creating families? I mean, last time we did a quick exercise. The type of family we're going to do today, it's a family that it's a little more elaborate, and rather than building it from scratch, I am going to give you some building pieces so that the exercise doesn't take that long. And what we're going to do is a bookcase, a parametric bookcase, and we're going to use some formulas as well. I see Dan joining us. Hi, Dan.
Hello.
Hey,
Made it.
you made it the last class.
That's it.
I saw you call in last Tuesday. Sorry about.
No, I saw your email afterwards, and I go, anyway. Yeah. And then Joel was still here at the office, and he goes, "Oh no, it got canceled to be." And I was late at the last meeting. So anyway, all was fine. I figured it out when nobody was there.
Okay. Yeah, I had this event that I was asked to be part of work and couldn't get away from it. Thank you for accommodating an extra day for me. All righty. As you must know, Revit 2023, it was launched on Wednesday. So we've been very busy the last month just preparing for the big global launch. And crashing. But let me give you, let me navigate to the end result of what we intend to do today. And then we're going to do a little exercise where we just pull some pieces together on the family creation side and create this parametric bookcase. So then I think I pasted a link to the data set we're going to use today. You might have not get it. I'm pasting it again.
Okay.
Sorry, I'm a little slow today. I'm very congested from allergies around this area. Bookcase. Open this. So this is the end result, what we intend to do. This is a family that flexes and an array distribution of shelf based on a formula. So just like we did a table last time, this is a family that has dimensional parameters, has a width, depth, height, a thickness, and is made of body. I call the body like all the envelope around this bookcase, and then it has a shelf nested in the family that it's array parametrically at a certain equally and at a certain distance. And so the goal of this family, and we're gonna, if you look at these parameters here, is to display how you can build from in a single family a wide range of variety of configurations just by the use of arrays and formulas. So I am changing here the height of the type properties of a height, and I'm also going to change the width of this the width of this to be 4, for example, and then the shelves and the arrays adapt to the changes in parameter values. I'm also going to change the number of items. There's a total of 6 shelves in this array. This is what we change here. And so if I want to change this to V5, 3, 2, this indicate the number of shelves. And so what's happening here is that the dimensional properties of the shelf, it's driven by a formula. So these 2 parameters that you see here, it's the depth and the width of the shelf using the exterior dimensional parameters of the body. And so I think I got this wrong. I think the shelf depth, it's depth minus 2 inches, not 1 inch. There you go. Now I don't have that gap that was there. And so and then we can apply material either as an instance or a type property and generate hundreds of variations in the project space. And this could be tall cabinets, wall mounted, or base cabinets as needed. I also have a family of a door that will be placed here, and we're going to review that as well. All right, this is the end product. I am going to close this family. Well, I'm going to open. We're going to start a new project from scratch, a new family from scratch. So I'm going to move this family over here. And so has everybody downloaded the data set? Then inside of these data sets, you have a family of a shelf, a family of a door, and a family of the body. What we're going to do together is we're going to, I'm going to, over the screen, I'm just going to display how these families were created. It follows the same process that we did on last class, but we're not going to build this together because the exercise is going to take us too long. But what we're going to build from scratch is the body, and we're going to assemble there both the shelf and the door as nested families and connect the value of the type parameters with the values of the body parameters. And so that process is really important to understanding in Revit, a method of concatenating values between the host family and nested family. All right, so I'm just going to open this family so that we understand how it was built. This is the shelf material. And now I'm looking at the floor plan. I think we've done this before. This is a simple extrusion with sketch line drafted at the reference level with 2 parameters, the depth, the width, and then in elevation, I'm not giving the thickness a parameter. I'm just assuming that this extrusion is 1 inch in thickness. This is the shelf, and something that happens here is that the material properties of the solid is concatenated to a parameter called shelf material. So in the list of parameters, in the type parameters, we created these 4 parameters: the depth, width, and height. Actually, I think I might not have this is the family. The family template. The family template comes already with the width, height, and depth system parameters. I didn't create them; they were already there. And the reason is that the template comes with a predefined list of parameters that are particular for this category of objects. You don't have to do this, but I'm going to create a new family from scratch using the casework template, which is what I did. And when I start with the casework, the template comes with these system parameters. So these parameters, you cannot remove them. These are system parameters that are specific to the category of the category of casework. So a lot of these have come preloaded with what the template provides you. And so the only thing I did in that to get this family ready was to create an extrusion, lock the boundaries of the extrusion to the reference plane. This is extrusion, and then give it a 1-inch thickness. And so these this shelf, if I change parameter values here, with 3 feet, notice how it flexes relative to the family center. And then the same with the depth. This family took a few minutes to create. We're not going to build it because we already reviewed the process here. But if you want to do this at your own time later on, feel free to craft it from scratch. The only parameter I created here from scratch was the shelf material. And the shelf material was created as a type parameter. And when I created that material, I'm just going to show you the properties. This parameter, it's reporting material units. And what that means is it's when you create this, then Revit's going to prompt for the material library. That's why, when you click on this cell, those 3 little dots that appear next to the parameter value is the result of selecting a material parameter type. And I made it a type because I assume that every variation of a type will have a different material, but it could be easily an instance if needed to. So this is the only parameter I created here, and then the depth, width, and height was already given by the template. Any question here on how this shelf was created? It's very straightforward. For the door, I think I would like you to open it with me. So I'm going to close the shelf because the shelf as a component is finished. But I'm going to ask you to open the family called door or shelf door. Here's the door. And this door as well was created with the template of casework. The way you know this is because the property window will report what is the category. And as such, it will disclose the family parameters that comes with it. The width, depth, and height were parameters in the template. The only parameter I created was this door material. If you open the family types and change some dimensional parameters, so I'm going to change the height to 2 feet and the width to 1. That is, you see how it flexes relative to the center of the family. Another thing you should check, if you select this extrusion, the solid extrusion, and notice how the material in the properties it's already concatenated. It's associated with a custom parameter. This is the part that I want us to focus on this class today. This is associate parameter. And what that means is that the value of this parameter is driven by a custom parameter. And that parameter, I call it door. When you hit this equal sign, it's the value of this is driven by a custom parameter called door material. And the door material right now is set by category. But when we load this family to the project and access the type properties, we can apply a material in the project. And that was my recommendation, that when we avoid applying materials in the family, but we actually create them in the project, and via instance and type parameter, we can apply a project parameter into the family itself. All right, but this is the door. So it looks pretty much like the shelf. I switched here to a 3D. And if I look at it, this door is like sitting on the floor work plane. Right? This is the working plane. The blue thing is the working plane, and this is the extrusion. So if I bring this family into another family, the way I have it here, the door is going to come associated with the family floor. And so a door nested into this cabinet needs to come vertical, right? So it needs to be able to, this family needs to be able to adapt to the vertical surface of the cabinet body. And so one thing, in order to enable that behavior, load this family into another family and make sure that this family assigned to a different work plane, look at the family category parameter properties right here. Family category and parameters. And there is a list of, the button is right here. This is the button. And if you look at the parameters at the lower panel, there's a parameter called work plane based. And this checkbox is very important because this is going to force the users to select a work plane in order this family to find the final orientation. So you've seen probably these families, when you drag and drop them, Revit is asking for what work plane needs to be hosted. If this is disabled, the family is automatically going to align the reference level of this family with the reference level of the other family. Because I know what I want, because the door is going to come flat on the ground. But if I enable this checkbox, work plane based, then I am making this family to become a face-based family. So the user has the ability to align or change the orientation of this door in any face available or any work plane available in the host. And then the other checkbox that's important is this one that's called always vertical. This is a way for Revit to guarantee that a family never tilts, never appears rotated, or appears in 3D, right? It doesn't appear rotated, or it doesn't get manipulated in a way that it doesn't make sense. I mean, a lot of casework are always vertical. You're never going to find a piece of wall-based cabinet turned upside down, but this is the door, and the door needs to be able to swap different orientations. And that's why I disable the checkbox that says always vertical. And so these two parameters available in this button, will allow the family to become a face-based family. Unlike the other examples we've done so far. All right, the other thing is I want a representation of the door swing. And so the door swing, it's, you know, that diagonal dash lines that appear in the door elevation. These lines are symbolic, and they are only going to display in elevation view. It's not a three-dimensional geometry, but it's going to be part of the physical representation of the door in elevation. And so let's do that. To do that, you go into the annotate tab. Again, if you're just catching up, open the door family in Google Drive. Click on the annotate tab, and there's something called symbolic lines. And I am in the floor plan. Symbolic line is only going to display in projection. And so I know that this door has 1 inch in thickness. So these lines are going to be placed at the reference level. That means at the ground level of this family. But I want to offset them by 1 inch, right? Because I don't want the line to be, I want the line to be at the surface of the door. And so what I'm basically doing is placing the line on the reference level and giving it a positive offset of 1. And so the door, the door is going to be made of segments of line. This is my first point, second point, and third point. And the type of line I'm going to use, it's a hidden line in projection. When it comes to line styles that have these brackets, these are called system line styles. You cannot delete or create them. Those are the line styles that comes with the template. And these are also subcategories inside the caseware category. And you can individually switch them off as needed. You can also create your own set of subcategories like we did in the last class. And you can control the visibility via visibility graphics in the project. But we're going to use the system line style, system subcategory of hidden lines. And then this is important. I want to make absolutely sure that this line snaps to the grid line intersections. So make sure that when you create this point, you type on the fly SI. This is snap intersection. In the intersection. And this is you have to type it. It's not going to display on the screen. But when you do that, Revit is going to snap to the intersection of the reference plane. So create a line, SI. That's the intersection of the line. And then, oh, sorry, that offset, it was not, I need to do it in the instance properties, not in the, let me do it again. So go create tab, annotate tab, symbolic lines, remove the offset for now. This offset is in the XY, is not on the Z direction. So reference plane, offset 0, do a line, then SI from this intersection, SI to this intersection. And that's what I want. You see how the pre-selection highlights the reference planes. When I do that, Revit establishes automatic lock relationship. So the endpoint of this line is always going to be associated with that grid line intersection. So it's very important that we type SI when creating this line. Then I'm going to do the other diagonal line, again, SI. And again, SI. If I don't type SI, I'm going to be snapping it to the line and it might not flex. All right, so these are the two lines. These represent the swing of the door. And now let's see if they flex. So when I change a dimension of width, oh, you see how that line over there didn't flex. So that's the purpose of flexing, to make sure that things are properly locking. So I'm going to delete it, do it again, annotate symbolic line SI to this intersection. And again, SI to this intersection, and then escape. Let's see if it flexes now. Width, it's 1. That's the height. The height seems to be flexing, and the width as well. So look at these lines, and what I was saying is that I don't want, these lines are hosted by the ground level, and I don't want the solid to block the display of these lines in the project. So the thing you're going to do that is we're going to select these two hidden lines, and we're going to disable this that says drawing the forward. Drawing the forward is giving a visibility priority to the solids, to the lines. So I'm going to disable that, and now it's going to be in the front ground. It's not going to be in the foreground. It's going to be in the front. And so one way to test this, is to load this into the project and see if it works. So you don't have to do this. I'm going to test it for us. I'm going to create a new project from scratch. And then I'm going to load this door family into the project. This is just to flex, to make sure that the family works. Load into the project. And notice how this is a face-based family, and Revit it's asking me for a face to host this family. And this was the result of that checkbox that says work plane. And you can check that, you can change a family to be reference plane based, to work plane based, or face based. So I'm going to do a work plane on the level 1, and I'm going to do it here. So notice that the this should be visible, and it is not. So something it's I need to go back into the door and fix that. So I think it has to do with the elevation, just like I suspected. Let me see if foreground will fix that. I'm going to load this into the project again. Okay, so that I take that back. I think this this family has to have the foreground enabled. Foreground is the front, right? Background is the one. So I gave you the wrong instruction there. What is my family? Okay, so these two lines, two diagonals, make sure they have draw in foreground enabled. My mistake. This should have stay as it is. And so that's going to make the line display at the front of the family as needed. So any question here? I could do other things like I could make this cabinet with inset glass, but I'm not gonna go there. What it will be super easy. You just define the thickness of the door frame, and then add a new extrusion of 1/4 of an inch and give it a material of a glass if needed to. I'm going to keep it like this, and then we're going to save it. And this is the door family, this door piece. So I'm going to close this one. And now we're going to assemble both the shelf and the door into a new body encasement. And that body encasement, we're going to build it from scratch. Any question? We have the two pieces for the bookcase. Now we're going to start a new family from scratch. So going to the file, new family, not project, family. And this is going to display for you the family templates folder. Open the English Imperial. And make sure you pick the right template and pick the casework family. Casework, and then you hit OK. There's another one here called casework wall base. This forces the family to have a wall as a host. I'm not going to do that. I'm going to just use the casework. And this template comes preloaded with the width, depth, and height parameters. It's ready for us to use. And here we're going to build this is going to be the front of the casework. This is going to be the back. This is the front. And the shelves are going to be nested inside the body, and we're going to array it a number of times in a vertical. So I'm going to create additional reference planes to help me craft the body. So I'm going to go to the Create tab and click Reference Plane. And we're going to create a reference plane an inch away from the casework envelope. This is to represent the thickness of the body. So an easy way to do that is creating a reference plane and using the Pick Line tool with 1 inch offset. That's going to make it easier enough. All right, reference plane. And then in the Draw tool, use the Pick Line tool, the icon that looks like an arrow with a green line. And then I'm going to create a reference plane based on another one at an offset of 1 inch. So change the offset to 0.1. And here you go. I'm going to create the first one on the left. Make sure when you see that ghost blue line preview, that's the location of the reference plane. That's where you click. So it's towards the interior. If you create one towards the exterior, undo and do it again, or delete it. So the offset is towards the interior of the body. I'm going to do this just on the right, the left, and the back. Now this one, this is the front reference plane. I'm going to keep that in mind because this is going to be the work plane that's going to host the doors. So the name of that reference plane is called front. I want these reference planes to always be 1 inch away from the exterior face. So I'm going to create a dimensional constraint using dimensions. So we're going to create an align dimension on the 3 edges. So dimension from here to here, place it and lock it. Another one here, place it and lock it. And another one in the back, place it and lock it. So this additional set of reference planes are going to become the body of the casework. And notice if I flex this, if I change this to 3 feet, the reference planes also move with it. All right, I also need to do the top and the bottom plate. So switch to in the project browser, switch to the elevation. Go to the front elevation. And I'm going to create another reference plane 1 inch above the reference plane and 1 inch below the height. So same thing, go to the create tab and reference plane, or you can type RP on the fly and use the pick line tool. The icon looks like an arrow and a green line. Give it an offset of 1 inch. And we're going to create one above the reference plane and another one below the height. And I'm going to give it 1 inch dimensional constraints and lock it. Same thing, going to the dimension, align dimension in the upper left side. And place a dimension at the top and lock it. The dimension have to be locked because I want to make sure that no matter what is the shape of the casework, that the body are always 1 inch away. So all right. So this is the elevation. This is the elevation. And before I do anything else, I also need to start thinking about the reference planes used for the shelf distribution. And so in a sketch, this is what's going to happen. This is the elevation. I'm going to create the I'm going to create a Control D. What this is giving me that big line. I need to create the space for the shelves. And in particular, I need the spacing between the first and the second shelf. So when we do arrays in Revit, there are 2 methods of doing arrays. Here you go. Now it works. An array in Revit, you can have, let's say this is an item that needs to be copied. You can do 2 ways of arrays. You can select the element you're going to array, this number 1, and then you select the last item or the last position, and then you select the number of times it's going to be copied, 4, 5, 6, 7, and then Revit automatically infill a distribution of elements between the first element and the last element. So this method is called array first and last. Because, give me a second.
Hola. ¿Cómo estás?
Hoy estoy en una clase, pero...
No te preocupes, puedes nomás abrir el garage y acá nos...
Rodolfo.
Ya.
Qué bueno. Sorry about that. So I was saying that there are two methods of doing arrays. Array is by picking the first and the last element, and then choose the number of items copied between the first and the last one. That's method number one. And then the method number two of creating an array, it's indicating the first copy, indicating the second copy, and then the number of times it needs to be copied. This is and. So this method is an array. It's called array first and second. Because you pick the first element, you also pick where the second element is going to be, and then the number of times it needs to be copied. And this particular method is what we're going to use to create the array distribution of shelves. And so I need a reference plane for the location of the first shelf and a location for the second shelf. And I'm going to do those with reference planes. All right, so I am in the elevation, the front elevation. Then go to the Create tab and hit the Set key, Set Work Plane. No, not Set, it's Create Reference Plane. Create Reference Plane. And this is the location of the first shelf. And then this is the location of the second shelf. Right now, the distances don't matter that much, but the first shelf is going to be placed here. And then the second shelf is going to be placed here. Actually, it needs to be on top. So it's on top of the reference plane. All right. Any question here? So this is where we're going to start looking at shelves and formulas. Have you noticed the extrusion, the solid editor always come at the end. I think the engineering portion, or we're basically programming a family to have certain parametric behaviors. And we do that all using parameters and reference planes. Then just at the very end, we added the geometry. Hey, yeah, Rodolfo. All right, so we are now going to create a parameter called the shelf height. And hey, stop. Hey, Rodolfo, vení, por favor. All right, so we are going to do a parameter called shelf height. And and the shelf height, it's a very simple concept. It's the height divided by the number of shelves. You agree? So this is the total height divided.
Hi. Wait, I'm in big trouble.
The height divided by the number of spaces. Because there's 3 spaces here. So a height divided by 3 is going to give me 2 shelves. The height divided by 4 is going to give me 3 shelves. And so I have to create 2 parameters. One is called the subdivisions, like n will be number of subdivisions, and then another parameter called the number of shelves, which will be the number of subdivisions minus 1, right? So if I have 3 subdivisions, I have 2 shelves. If I have 4 subdivisions, I have 3 shelves. I have 5 subdivisions, I have 4 shelves. And those are things that I can control via parameter. We're going to create some parameters here. And the first parameter we're going to create is the number of subdivisions. So go into the family types. The button is this one. And we're going to create a new parameter. The second icon from the lower left. And we're going to call this NS. Let's just call it n subs, the subdivisions, and it's a type parameter. They're going to report parameters of length, and then we need to have another one. Actually, my bad. This doesn't need to report distances. This needs to report integers, because it's not about distances, it's about quantities. So I'm going to delete it. My apologies. So select n sub, and we're going to delete it. Let's do it again. So you, in the family types, create a new parameter and call it n subdivisions. It's a type parameter, and it's going to report integers. It's not going to report numbers, because you cannot have 1.5 shelves. It's always going to be an even or an odd number. No decimals. So number of subdivisions. And I'm going to create another parameter, which is the number of shelves, which is number of subdivisions minus 1. So a new parameter, I'm going to call this n shelves, which is the number of shelves in the cabinet. I went too fast. New parameter, n shelves, and it's going to report also integers. And so the number of subdivisions is the input given by the user, and the number of shelves is the number of subdivisions minus 1. So you can use formulas inside Revit to concatenate the value of one cell into another one. So the number of shelves equal the number of subdivisions. Make sure you type it exactly the same way we created. So it will be number of subs minus 1. So if I have 2, it will be 1 shelf. If I have 3 subdivisions, I'm going to have 2 shelves. And this is important because when I create the array, I need to define how many items are going to be copied in the body of the casework, and that number of elements is this one, number of shelves. All right, any question here? Is anybody behind? Somebody want me to repeat anything?
Do you repeat the, my internet got disconnected. Could you repeat the array, the lines, those shelf lines that you made just really quick?
These two?
Yeah, those 2 lines, how did you get those?
Okay, it's, I'm gonna delete them. It's just go to, I am in an elevation, the front elevation. And then go create reference plane. And I just eyeball it. I'm gonna eyeball, this is the location of the first one. And then this is the location of the second one.
Oh, okay, I missed that part. Okay, thank you.
Yeah. Now, by now in elevation, you should have dimensional constraint at the bottom, a dimensional constraint at the top. Make sure this is locked. If these are not locked, they are not going to flex, and the thickness is not going to be preserved. All right, so I'm going to close everything except the front and the right. The front and no, the plan view and the front. And then I'm going to tile it, WT tile it. So I have the elevation here, I have the floor plan here. I'm going to be working in both at the same time. And in plan view, I have the depth, the width associated, and then I have dimensional constraint of 1 inch on the left and the back and on the right, left and right. All these 1 inch dimension must be locked. And then in the family types, I created 2 new parameters, integer types, number of subdivisions, and number of shelves, where the number of shelves is the number of subdivisions minus 1. All right. Hope everybody's with me here. All right, now I need to create a new parameter called the shelf height. And the shelf height is the height divided by the number of subdivisions. In other words, this is the shelf height. And the shelf height is the height divided by the number of subdivisions. And so this is a new parameter, and I'm going to use that to drive the location of the first shelf. And the most important part here is to make sure that the first shelf is properly placed. In elevation, I'm going to create another parameter. So you go into the family types, and I'm going to create another dimensional constraint. In the lower left side, click on the new parameter, is the icon that looks with a little star. And I'm going to call this shelf underscore height, or shelf H, to make it easier on us. Shelf height. And it's going to be length, units of length, and it's a type parameter. All right, the order of the parameters here, it's something like I can control using these 2 buttons. These allow me to remove the default alphabetical order of the parameter and customize it. And so the shelf height is something I want to have at the end. I mean, after the depth, height, and width. And I'm going to reorder here. So maybe the width goes first. So select the width parameter and move it to the top. So it makes it easier to think about creating types. So you type first the width, then the depth, and then the height, and then the shelf. This is the order, the proper order. And so the shelf height equals the height. And this is a formula. And I type it in the formula column. The shelf height is the overall height divided by the number of subdivisions divided by n sub. And you have to type exactly with the matching case the name of the parameter. Sometimes it's correctly spelled, but we're not matching the casing, and Revit doesn't understand what the parameter is. So parameters in Revit are case sensitive. So it's the height divided by the number of shelves. And when you apply it, notice that it grays out. This is something that's going to be changing based on the height of the element. I'm going to flex this and change the height to 4. And now you see that the cabinet is the shelf height is 1'4". If I change this to 5, then the shelf height is 1/8, etc. I'm going to return this to 3. Apply. And the shelf height is ready to be used. And now I need to apply that to the first and the second dimensional distance here. So in the elevation, I have the elevation on the left side here. I'm going to draft an align dimension from the reference plane, from the bottom of the reference plane to the first reference. Place it. And let's make sure you pick the reference plane. That's your first snap. And then the first shelf. And then this dimension, I'm going to associate it with the label shelf height. So here I'm associating in the drop-down list of the labels. I'm selecting the shelf. So you select the dimension, and then on the label, pick the shelf _h as the parameter. All right, so this shelf should flex with the family. And then I need to also define the height of the second. So remember, I'm going to use an array method that's called the first and second, meaning I pick the first element, then the location of the second element, and then I pick the number of elements, the number of subdivisions. All right, so I'm going to do another dimension. Go to the align dimension tool in the upper left side and create a dimension from the first and the second reference plane. And then call this parameter the same, is the shelf height, shelf _ height. And I'm going to associate this dimension with the label in this drop-down list, the shelf height. All right, so when I flex this family, I'm going to see how it changes in elevation. I'm going to make the height of 4 feet. And notice how the height readjusts. I'm going to make this 5. The height of 5. And it does readjust. And if I increase the number of subdivisions, say this need to be now 4, then the distance between the first and the second element readjusted. So I can have 3 shelves here. If I increase the number of subdivisions to 5, I'm going to have 4 shelves. And then the distance between the first and the second also gets readjusted. This is the type of parametric behavior that I was going after to create the array. So make sure that we have this parameter created and applied to the dimension. And let me know if you're behind, or if you want me to repeat anything, or if I'm going too fast. We okay? All right, so we have the I'm going to hit OK here. In elevation, we have everything in place. We have the reference planes defining the thickness of the body, reference planes defining the location of the shelf, and now it's time to assemble it all together. So I'm going to start by bringing the shelf, and I'm going to do this in the floor plan. Oh, another thing I'm going to do in elevation before I do anything else is select the very first shelf reference plane, and I'm going to call this, give it an identity data. I'm going to call this first underscore shelf. That reference plane represents the location of the first shelf. And then select the other one, the second reference plane, and give it a name as well. This is going to be the second underscore shelf, because it indicates the location of the second shelf. And these are going to be used as work planes. All right, so I'm going to hit enable the reference plane, the floor plan, and I'm going to bring the shelf. So before I do that, I need to enable a new working plane in the floor plan. So under the Create tab in the floor plan, hit the Set Work Plane. And in the list of working planes, we're going to pick the first shelf, reference plane, first shelf. What I'm basically doing is elevating in the Z direction the location of my working plane. So you can show it. This is a working plane when I select it. That's my working plane at this elevation, the elevation of the first shelf. I'm going to switch that off. All right, let's bring the shelf. And so the shelf is going to, you go to the Insert tab, and then you go into Load Family, and navigate to the location of the shelf as you download it. I'm going to open it. I'm going to insert it directly from the Google Drive because I have it mapped here. But if you download the data set in the chat panel, just go into the family creation bookcase and bring the shelf family. This is loaded in the project, but it hasn't been placed yet. To place the family, you're going to create, and then hit component. And this is going to bring the last family in the project. And I'm just going to place it loosely on the reference level. Now notice how this family, because it has a reference plane, it loves to be associated with the reference plane. And that's something I can change. When you select the shelf, you can force it to be hosted by a different level, and I don't have another level here. But I can make it, I can just move it, align it, and lock it. So in the elevation here, if you select the case word, notice that I can change its elevation anywhere. I can raise it. I can just select and drag in and out. What I really want to do is to fix the location of this shelf, or align the elevation of this shelf with this reference plane. And I'm going to use the Align button. And I don't know, I think we've used it in the past. align. And the align button, it's this one here. When you align something, you pick the destination first. So where is going, that's the first click. And then what is it that you're bringing? The face of the shelf. That's the second thing. So where is it going? What is that you want to align? And then you lock it. You're going to be presented with a lock, and make sure that you lock it. If you miss that chance, you have to repeat the command. All right, we're going to lock the shelf in the vertical using the align command. So align. We're here under the modify tab, align. The shortcut is also AL. And the first click is destination. Where is the shelf going? The shelf is going here. And what needs to go there? The face of the shelf. And here, immediately after that, you lock it. And so in Y, in Z, this shelf is locked with the reference plane. But not only that, I also want to be able to lock it in the Y direction. So in the Y direction, I'm also going to lock it. So the back of the shelf needs to be aligned with with this reference plane, right? And I'm going to do the same thing. It's going to be an alignment. Again, go to the modify tab, the align tool. The align tool, or the shortcut is AL. And you hit the first click is where is it going? The second click is what is that you're moving? So where is it going? Towards the back of the back surface of the shelf. What is that you're moving? The back of the shelf, and lock it. Escape. So this is important because then the bookcase can flex, and then the shelf is going to follow the location of the reference plane. All right. Any question here? We align the shelf in the vertical using align and lock. We align it in the floor plan in the Y direction using align and lock. The next thing is a very important step. And this is one of the goals of this class. I'll show you how to concatenate the dimension of a shelf with parameters in the family. So when you select the shelf, you can access the type properties using the edit type. And this is going to disclose the parameters inside the shelf family. And these parameters over here have a toggle, which is a way to concatenate type values with the host family. What does that mean? I have a way to connect the width of the shelf with the width of the body. Or I could also concatenate the depth of the shelf with the depth of the body. Now, the problem here is that is not the width of the shelf is not exactly the width of the cabinet, because the width of the cabinet is measured from exterior surface to exterior surface. The width of the shelf is the width of the body minus 2 inches, right? Minus the left thickness minus the right thickness. That is the shelf width. And so I need to build to build a parameter that reflect that dimension. And then the shelf depth is going to be the distance. I'm going to cancel here. The shelf depth is going to be the distance from here to there. And the shelf width is going to be the distance from here to here. So that is the width minus 2 inches. And here is the depth minus 1 inch. And I'm getting very formal like it here, but that's what Revit is all about. It's about engineering the parametric properties of objects. So I have to create two more parameters. A parameter called shelf width and shelf depth, and apply formulas to it. Okay, so let's go back to the family types here. And I'm going to create now two more parameters. One's called shelf underscore width, and another one shell underscore depth. So click on the icon that looks like a paper with a star, and it's going to be shelf underscore width, and it's going to report elements of length. It's a type property. I'm okay with that. Shelf width. And shelf width, I'm going to move it towards the end. So using these move parameters down, I'm going to relocate the parameter row all the way to the end. And the shelf width equal the width minus 2 inches. 1 inch is for the right thickness, another inch is for the left thickness. So it's a total of 2 inches, the one that defines the shelf width. Apply. And notice that when you change the width, the shelf width is going to change. All right, the shelf depth is going to be the depth minus 1 inch to account for the thickness in the back. Actually, no, it's going to be 2 as well. Because I also need to take into account the no, you're right. It's only 1 inch. Sorry, thinking aloud. Again, I'm going to create a new parameter, and this is going to be called shelf underscore D for depth. Shelf underscore D. Type parameter length units. I'm going to move the relative location down using the move parameters down. And the shelf depth equals the depth depth minus 1 inch. And then this is all parametric. Changes in the width and depth are going to change the values of the shelf width and shelf depth. And you see where we're going with this. I'm creating these two parameters so that I can concatenate the width and depth value of the nested family using those parameters. Any question here? Again, this is all like programming element behaviors. Anybody want me to repeat instruction or is behind? Okay. So hit OK here. And now I'm going to apply those parameters to the shelf. So select the shelf in the floor plan, and then go to the edit type to access the nested type properties of the shelf. And the width of the shelf equals the shelf width in the host. And I'm going to concatenate those parameters using this toggle, associate family parameter. So let's start with the width. The width of the shelf equals the shelf width parameter on the host. So, and then the height, the depth of the shelf equals the shelf depth. So the shelf is acting like a marionette of the family. It's adapting to the host parameter. So no matter what dimensions the body have, the shelf is going to adjust its relative location. The height doesn't matter because I didn't define any thickness. And then the other thing I'm going to do is make sure that I also concatenate the material of the shelf with the material of the body. And I'm going to do that creating a parameter on the fly. So in the type parameters, I'm under the shelf material. I'm going to create a new material parameter on the fly. And this is so that I only have to apply the material once. I define it to the body, and then the shelf inherit the materials of the body as well. So select the shelf, edit the type properties, select the shelf material, and hit the toggle button at the end of the cell. And this is going to, I can create a new parameter on the fly using this new parameter button, this icon with the little star. And I'm going to call this body material, body underscore material. And the type parameter, it's automatically detect that it has to be material in order for these values to be connected. And that's it. Body underscore material, type property, hit OK. And then hit OK. And now the shelf is no longer, the shelf material no longer depends on itself. Now it depends on the value of the body material. So hit apply, hit OK. And when I look at the type parameters, here's the body material. This parameter is something I'm going to define in the project. So as soon as I define a material in the project, this material is also going to translate into the shelf and the door. All right, these are all smart components. Any question here? All right, so then I think I align this shelf on the Z direction. You can see by this, if you select it and you see this locked, I mean, that is locked in the Z direction. And then it's also locked in the Y direction. You see that lock here. I also need to align these, lock this shelf on the X direction. So I'm going to use the oh, you know, I am looking at the formula, and I also need to concatenate the shelf depth. As you see, I have this little, the shelf depth, it's the depth minus 1 inch. So select the family, edit the type properties, and then I don't know what happened. It's I need to concatenate this to the width and the height. So the width of the shelf equals the shelf width, and the depth of the shelf equals the shelf depth. Apply. Now it is. Now it's what it needs to be. Again, repeating, I select the family, I edit the type, and then there are three parameters I have concatenated. The shelf material, and notice how they are in gray. The depth is also in gray, and the width. This is concatenated with the shelf depth. This is concatenated with the shelf width. So dimensionally, the shelf has the right size. Now you just need to align it in the X direction. So I'm going to use the align button again. Modify tab, align, and then you go to the align to where, to the right reference plane, the shelf, and lock it. And this shelf is ready to be is ready to be arrayed. Now let's see what happens when I flex the family. Go to the family types and change the width to 3 and see what happens. And notice now that the shelf, it's reacting to changes in the parameter values. Change the height to 6. The first location is flexing. Change the height to 5. Change the number of subdivision to 4. Change the depth to 1 foot. And the shelf, it's reacting to changes in the body. All right, any question here? Because now we're getting to the end of the exercise. I mean, this is the hard part. The hard part is to set all these behaviors and flex the family and make sure that it's behaving the way you expect it to behave. All right, so let's sort out the array first, and then at the very last, we're going to do the body. So we're going to use the array command under the modify button. This is the array command. And the method I'm going to use is first, second, and number of items. So an array, with an array, you select the first element, which is this shelf. Then you select where it's going to go second. So this is where this shelf is going to go second. And then you tell it how many times it needs to be copied. This is n. And so the distance between first and second, it's something that is going to be driven by this shelf height parameter. And then n is the number of shelves, right? Which is the number of subdivisions minus 1. All right, so we're going to do that. We're going to do an array in the elevation. So activate the front elevation, select the shelf, and then we're going to array it. Array, the shortcut is AR as well. These are the two methods of creating arrays, using the second method or using the last method. I'm going to use this method, the second, the distance between the first and the second, and the number of elements. What I want to make sure is that this array always is vertical. So I'm going to constrain it, and constrain it forces the array to always be perpendicular to the first item. So I'm forcing a vertical constraint. I'm using the second method. It must be a group and associated. And then the number of elements, I'm going to set 3 for now, 3. All right, first click, it's a point on the first shelf reference plane. This is my first click. And then second click, a point perpendicular on the second shelf reference plane. And that's it, then escape. This is the array that's happening. It's the first element array a number of elements. And one thing I want to do, and this is the last step, and it's concatenate the number of elements to the family parameter. So this is how we do that. You select the array, and you see this here. This is the n value of the number of elements in the array. And this is it's like a dimension. You can select it and associate that dimension to a parameter. So you select the group, select the array number, and in the label, in this drop-down list, connect it to the number of shelves, which is the number of subdivision minus 1, the formula. All right, so the number of elements now it's driven parametrically. That makes sense?
Can you repeat that?
Okay, I'm going to undo this. Did you finish the array?
Yeah.
All right, so when the array is finished, it will create this group of elements. Select the group of elements, and you're going to see that there is dimensional representation of the number of elements. Is this bracket with the number 3? You can actually click there and change this, like make the number of elements be different, 4, 5. But these can, if you hover over it in highlights, you can convert this parameter or associate this with a family parameter. So select the number of elements here. And then in the options bar, there's a drop down that list of the parameters that can be associated with. And I'm going to associate this with shelves, number of shelves, which is the number of subdivisions minus 1. And now n is connected to the parameters. And just to make sure that it works, you can go into the family types and change the number of subdivisions. If the subdivision are 5, they're going to be 4 shelves. Oh, but it's not equally. Oh, I know what's happening. I know exactly. That's why it's good to do this. So when I flex this, notice how the second element is not responding to the equal distribution. And that's because I have one more alignment to do. Again, I'm just changing the number of elements here. I'm going to return this to 4. And this is what I'm going to do. I need to force the second shelf to be aligned with this reference plane. And that's the last alignment I need to do. So align where the second reference plane for the shelf. That's where is it going? What's going here? The top of the second shelf. And lock it. Now it should work. Again, align. I'm going to repeat it. Align to the second reference plane. Not this one, this one. The second reference plane. The top surface of the second shelf. And lock it. And now we can flex it. Go to family types and change the number of subdivisions. Let me make it 5. And now it's working as expected. I can make it 6, make this 7, and it's beautiful. It's a beautiful array. I'm going to leave it at 4 for now. And let me know if you have questions, if you want me to repeat anything here. Also, check the depth and see if all the shelf flex. I'm going to change the depth to 2. Oh, here is another problem. And I know how to solve this. Notice that when I change the depth, the array seems to not to align. And that's something that I have to fix in the right elevation. So I have another alignment to do on the right elevation. Notice how the shelves are not extruded perpendicular to the. I need to force the second shelf to be locked to the back of the reference, the back of the body. So in other words, the second shelf needs to align with this reference plane, and I need to lock that relationship so that the third, the fourth, and the fifth are also display the same behavior. So on the right elevation, I'm going to align to this reference plane, the back of the array, and lock it. Again, I'm in the right elevation. I'm going to repeat. I'm going to do align to the back of the back surface, internal surface of the bookcase, the second shelf edge, and lock it. Make sure to lock it. And now this should flex regardless of changes in the depth. Now the depth is 1. There you go, beautiful. 2, it works. And you can also flex it, the number of subdivisions, 5, 3. The only limitation on the number of subdivision, you cannot have these, you cannot have the number of subdivision as 2 because the number of shelves is 1 and the array is going to break. So the array needs at least 2 elements. That's the only limitation on this method. I cannot have just 1 shelf because the array need 2. It need the first and the second. That's the method I chose. You're going to see if I change this to 2, it's going to give me an error. Yeah, and I'm going to cancel here. So, all right, so I think the shelf is behaving as expected. Now I just need to bring the shelf, the body, and the door. So let's bring, let's build the body. And I can do that here in the floor plan. It's going to be easy. So this is what we're going to do. We're going to create a box, a solid box around the outer border. And then we're going to carve this big box with a void, intersect the void with a solid, and that's going to give me the shelf, the body of the bookcase. All right, we're going to do it in the floor plan. So go to create. Make sure we double check that our working plane is the reference level. Again, activate the floor plan and double check where it said set. Double check that your working plane is the reference level. Floor plan, set, and select reference level. This is the work plane that's going to host the sketch lines. And then a simple extrusion. Create extrusion here. Use the rectangle tool and snap to this intersection in the upper left side in the floor plan. And then snap to the opposite side. There's no need to lock if we snap to the reference plane. If we miss aligning this to the reference planes, then we have to lock it. But just to make sure we can lock it, that doesn't hurt anybody. You can lock it. Notice in the elevation how the sketch lines are hosted by the reference plane. And then hit the green checkbox. In elevation, this is the solid. The height, it's something I need to fix manually. What I'm going to do is grab the handle at the elevation and snap it to the top reference plane and lock it. We're going to do that in the front elevation. So select the solid, grab the handle, stretch it all the way to the top and lock it. But right now, this is a big cube, solid cube. Let's see if it flexes. I'm going to change the width to 4, the height to 4 again. And notice this, the big solid body, it's working. All right, so now I need to do the void. And the void is something I can do also in the floor plan. The intersection of the solid and the void is going to give me the cabinet body. And I'm going to go back, do this again in the floor plan. So this is one of the last steps. Then we're going to bring the door, and that should be easy. All right, so in the floor plan reference level, let's create another solid. Go create. Here's the thing, don't pick the extrusion, pick the void form. And in the drop-down list of voids, there's a void extrusion. That's what we need. We want to carve the opening for the cabinet body. So in the drop-down list of create void extrusion, select again a rectangle. And again, we want them to snap at the intersections. What we do, you use the SI. SI, snap intersections. You type that on the fly. SI, this reference plane, an intersection here, and then go all the way here, and then SI again. This is going to force to snap at the reference plane, and you can lock it, lock the sides, and then escape. And then hit the finish. This is a void extrusion, and in elevation, I need to snap the top of the void and lock it to the lower reference plane on the top. And I also need to lock it right here. So using these handles, drag the handle, stretch and snap and lock. And the one from the bottom too. Drag, stretch, and lock. So you're gonna lock the void in the I want to switch to a 3D, and you should see that there should be an opening already. Let me know if you don't have that. So the body is a solid, and then the interior, it's carved by the solid. We can flex this 5, depth 1, number of subdivisions. It cannot be less than 2. That's the only limitation. But this seems to be parametrically working. I'm going to return the depth to 2, the width to 4. And we're ready for the last step, which is bringing the door. And so the door is going to be hosted by this reference plane, the front reference plane. And remember, when we created the door, it has symbolic lines that are going to be displayed in elevation only. And so for this, I'm going to use the front elevation. And I'm going to bring the door family. So you go to the Insert tab, Load Family, and navigate to the place where you have saved the door. We started with this one, this exercise, and then hit Open. The door now is loaded, and now I can drag it and drop it into the front elevation. So under the Casework family in the project browser, look for the door that we just loaded, drag it, and drop it. Now notice in elevation how the door is towards the back in the floor plan. So we need to fix that. We need to bring the door in alignment with the front reference plane. And I also need to concatenate the dimensions of the door with the dimensions of the cabinet. So the door width is going to match the cabinet width. And the door, I think this is the door height, is going to match the door height here. But I think the door, this is called the depth. This is the depth parameter in the family. So the depth is going to equal the height. So let's do this concatenation, and then we lock the alignment of the door in X, Y, and Z. So you select the door, and then edit the type properties to access the dimensional parameters of the door. Here's the width. The width of the door, I'm going to associate it with the width of the cabinet. You can apply it and see this is the width of the cabinet. And the height of the door is going to be associated with the height of the cabinet. Apply it. And so the door is inheriting the properties of the host. And lastly, the door material. The door material is going to match the body material. And my door is dimensionally correct. I just need to lock it in X, Y, and Z. So again, select the door, access the type property. The width of the door match the shelf width, the body width. The door height matches the body height, and then the door material matches the body material. So let's lock it in elevation first, and then in X and Y direction. So you don't have to lock the top and the bottom. You only have to lock one of the sides. So I'm going to align the bottom of the door to the reference plane. So on the Modify tab, align to the reference plane the door and lock it. I'm done with the alignment in the Z direction. And now I need to do the same in the floor plan. So in the Y direction, align to the reference plane, the back of the door, and lock it. And then in the X direction, align to the right reference plane, the right edge of the door, and lock it. And there you go. This is my cabinet. This cabinet should flex in X, Y, and Z. The width is 3. The height is 4, 5. And notice how both the door and the shelf are flexing. And the number of subdivisions cannot be 2, it has to be more than 2. Now in 3D, notice that you don't see the cabinets, the shelves. We can go back and edit the door to have a glass material. Let's see, the door, we can disconnect it from the body material and then just directly say this is glass. And so it's gonna make the whole thing a glass door. But we can edit the door so it has a frame as well. But I'm looking at the clock, look like we are at time right now. And this is a parametric family. All we need to do now is to create different types and we should be done. And then again, the types should be going to the family types and add new types based on dimensional size. So maybe the first one is called 36 in width plus 36 and width, depth, and height with 18 and 36. And you can also disclose the number of shelves there, -3 shelves. So 36, 18, and 36. And number of elements is 4. This is my first type, 3 shelves. Let's do another one. And you can continue, and this is a 48 by 30. The depth, it's 2 feet. 24, and the height is maybe 36, and this is going to have 2 shelves, no, 3 shelves, and modify accordingly. 4 by 2 by 36 in height, and 3 subdivisions. And continue creating your types. You can have, with the same family, you can have a wide range of different families. And then save this family as, you can call it parametric bookcase. Here, and then just load it into the project. We'll create a new project and using the architectural template and load the family into the project, and you can assign materials there. Load into the project. Here's the casework. Here is in 3D. Switch this to shaded, and you can have your different types here. And then you can create new types based on existing types in the project. Duplicate, I want to make this a very tall one. So it's 60 by 18, no, 60 by 18 by 72 in height. It will be 5, 6, 5. This is a big, obviously the door, this is a single door, but if I wanted to do this with 2 doors, it's just a matter of creating another parameter, like door width equal the width divided by 2. So it'll be half of the cabinet width. And then you mirror the door, align it to the right and to the left, and you have a 2-door cabinet if you wanted to do that. I only did it here with 1 door. You can also embed the hardware in the door. And the hardware could be aligned and locked to the center of the frame if there was any. We didn't go there to this exercise, but I think the process is very similar. The material is a type property, so when you select it in the project, edit the type properties, and here look for a material browser, which is in my other screen. I'm going to do for a wood. The advantage of doing it in the project is that you can share this material with other families as well. And because it's a type property, it applies it to everything except the door. The door doesn't get. These look opaque because the door has a glass, and so that's why it looks like dark. Oh, you know what? I don't think I connected the body to a material parameter. That's why only the shelf are changing. So I'm going to go back to the family, select the body solid. Yeah, I failed to do that. The shelf, connect the material to the body material, and then load it into the project. Now it's going to inherit the property. So edit type, body material, wood, and it should do it for the whole body. And you can have different casework with different materials, a different number of shelves. In an elevation, the door direction appears. You can also add flip controls, so you can flip it in elevation if you want to. And it'll be easier for you to use. Again, I'm going to do that very quickly. If I go back to the family and open the front elevation, I can add a flip control under the annotate. But this doesn't have flip controls. The flip controls, I think they are limited to plan view. So I can flip it in plan, but not in elevation. Let's see here, you see the controls. I can apply a global horizontal here. Load it into the project again. And then I can flip using the controls. And that will be reflected in the elevation as well. So this is flipped. All right, so hopefully it works on your end. I know this was, this family is a little more elaborated than the first one, but that was the intention, show you the power of connecting nested components and the power of using formulas in dimensional constraints And so the user in this bookcase is limited to define the width, depth, height, the body material, and the number of subdivisions. And that takes care of everything: the width, the dimensional parameters of the shelf, the dimensional parameters of the doors, and they are all connected as a whole. And this makes it for a very clean family. And you can think about using the same logic for other type of casework, like base cabinets or cabinets with shelves or with drawers, for example. Number of drawers, you can do the same logic as long as you have the right families concatenated. If you want it also, you can have the dash lines of the shelf behind as symbolic lines. That's something you would add to the shelf. And so the front elevation of the shelf would have those dash lines. And so as you array them in different elevations, you will see in elevation the different dash lines. Okay, any question on this? I think we are at time. This has been broadcasted, so you can, if you fall behind, you can watch it, or if you want to stick with me after class, welcome to do so. Hopefully this gives you a good understanding, not only this how to create families, but Revit in general. You have access to the data sets. Feel free to use them as needed. There will be alive in the Google Drive and also the recordings in the YouTube channel. Any question about this or anything in general about the course?
Could you just one quick question? The family type names. How did you save that? It doesn't hold for me. Like when you create the 4 foot wide versus 3 foot wide.
To create new types in the family?
Yeah.
All right, so I am here in the family. Go to the family types. And then here's how you create a new type. And then the name, I usually name it based on width, depth, height, and number of elements. And the industry standard for furniture is use inches. So I use, if I want a cabinet to be 36 by 48, no, by 18 by, and the height be 60. That's a new type. Number of shelves, 4. This is just a name. This has nothing to do with the dimensions. I created a new type, and then I changed the parameter values. So the width is 3. The depth is 18, 1 foot 6. The height is 60 inches, or 5 feet. And the number of elements is 4. And hit apply. And this creates a new type in the background. And you can continue adding more as needed. I'm adding types in the family. But if I load this inside the project, I can also create new types on the fly. Like I am in the project here, and we build types just like we've been doing throughout the class. Edit the type, duplicate, and change parameter values. You can do it in the family, or you can do it in the project. That makes sense, Jason?
Yeah.
Okay.
Thank you.
Any other question? All righty. Well,
for questions unrelated to this, to today's course.
Okay. You want to do it now, or you want to do it with me?
Could wait.
Okay.
Yeah, I have also some questions.
Okay.
Yeah.
All right. Well, if the rest is okay, then feel free to disengage. It's past 7:30. Thanks for sticking with me. Hope you like the class and that you learned Revit. You have my contact information in case you have any questions. Feel free to refer me to your colleagues for the summer course or for coming fall. I do this because I like it, and then any feedback, feel free to email me or send me a note. We're working with the school to provide AIA units. If you're a registered architect, I think it's starting next class. I hope that by the fall, if this is approved, it will give you plenty of CE units to fulfill your requirements. So we hope to offer that in the future, next class. Okay, guys, if you don't want to stick around for 101, I hope you have a great weekend. Have a good Revit afterlife, and hit me up if you have any questions. Thanks, everyone.
Thanks, Cesar.
Thank you.
Thank
Tom.
you.
Thanks, Dan. Thanks, everyone. All right, who goes first? Sabita?
Sure, yeah. So I have some problems with these things. Like when I do staircase, right? The upper floor steps, I can see. I want them dotted, but I could not make them dotted. Like after the cut line, right?
Mm-hmm.
I could not make them dotted visibly.
So this is on a project. In a Revit project, right?
Yeah.
Let me show you here. I'm gonna create a new project. And you do a stair from a first floor to a second floor.
Right.
And when you build it, you want to have the half portion of it dotted.
Visible and half is dotted. Like
Okay.
Yeah.
So this is a stair going from level 1 to level 2.
Mhm.
And these are the dash lines you want solid. Is that what you want?
No, the same way, but mine doesn't look like that. All lines I can see.
All the lines are solid.
Yeah.
You want them to be
dotted. Yeah.
Dotted.
Dash, yeah.
Okay. So two things. You see this break line here?
Yeah.
Do you see that break line on your end?
Right. Yeah, I can see, yeah.
All right. And so the dash lines are subcategories of the let me bring the visibility graphic here.
Yeah.
The stair parameter, the stair category have these above cut marks, above nose lines, above outlines, above riser lines, and above supports.
Okay.
So the above nosing line, it's it's the line, the outermost line of these double lines. The outline are this is just the outline. The supports are these double line after that. And then the risers is the second line.
Right.
And so these by default have the above bracket. But you can override them. I mean, I'm going to override, let's say, the risers. And I'm going to make it, instead of being above, I'm going to do a pattern that it's solid. Solid here.
Okay.
You see how they became solid?
Yeah.
So if you change them by default, make sure that there's no override here.
Okay.
Or also make sure that the global setting of these line styles are in the on the Manage tab, line styles.
Okay.
So these are the the system lines. Everything that has brackets are system lines, and the above is not here, so it's not. I think it's part of the object styles, not the line styles.
Okay.
And so go to object styles and then go to the stairs, and make sure that everything that says above does not have a solid line pattern.
Okay.
As
Okay,
long-
sure.
And this is in object styles,
Okay, next time.
and then it should work.
Sure, sure. Yeah, and one more thing is how to divide line or any arc.
Divided.
Divide by like 5, 3. I want to divide the line.
That's a good question. There is not an easy way to do that, other than
Only equal is there, right? But not.
That's correct. You can array it.
Okay.
But honestly, I think there is a Dynamo script that could do that. Dynamo,
Okay.
it's a custom script. I don't think there's an out-of-the-box way of like subdivide this. No, I can't think of a way out of the box without going into scripts. I can give you a copy of the script because I have that there.
Sure,
But,
yeah.
I mean, put a script together is like teaching you how to do, how to write in design script. And that's not going to take like 5 minutes. But I'll send you an instructional video that show how to do that.
Sure, yeah, sure.
Okay.
And the last one is like when we do design options, right? One, option 2, but the option 1 is like main level, same, they have same things, right? Main level plan and the option 1. Right, when I do option 1, like same thing copies in the main level, right?
When you create design options and you have
Yeah, design options. Maybe I can share. I have this.
Yeah, sure.
You cannot share.